Welcome students, my friends. In this video we're going to talk about how to solve the following integral. In particularly, what I want to show you on this video is not how to solve it, but mostly how to change the limits of integration according to when we do trig substitution. Because so far in all the videos that I've given you, I always go back to the I don't keep myself in with angle theta. I always go back and once I find the antiderivative, I go back and change it back to x's, the original x function, the original x variable. So what I want to do this video is basically, once I change this to theta, d theta, I want to make sure that I want to change this to angle as well, to theta angle. And then at the end, instead of going back to dx, I just keep d theta and plug in my change limits, the limits I change. Okay, so first of all, I wanna give you how this function look at x. So the integral goes from 0 to 3, and then the function that I'm integrating is x cubed over the square root of x squared plus 9. And if you graph this function on Mathematica or a software, it will give you something like this. So here is about 3. Here is negative 3. So when I change the limits, I have to make sure that I'm integrating between here and here. So I'm in quadrant 1. Quadrant 1 of the coordinate system. And that's gonna be crucial when you're computing your limit changes. Okay, so the integral as it is, we're gonna solve it using trig substitution. First of all, once I'm not gonna solve this integral, but we're gonna look at the solution, and we're also gonna look at the most important thing, which is change the limit of integration. Okay, so remember, when you have radical and you wanna do trig substitution, concentrate on the radical. So when you do the radical, this pattern here that you have, u squared plus a squared, this pattern here, and then you have the square root, this has a pattern. So this this radical becomes, once you change the d theta, it will become 2 we have 3 here because this is 3 squared, so a squared is 3, so it will be 3 secant theta. Okay, so now a, as I said, is 3 because 3 squared is 9, and also we know that x is equal to, gonna be equal to 3 tangent theta. So from this specifically from this equation here, we can obtain the new limits of integration in terms of theta. The way you do it is as follows. So for x, you let it equal 0, so it will be 0 equals 3 tangent theta. So 0 over 3 is 0, And when is tangent theta here equal to 0? When theta equals 0. So this one will stay the same. But when is tangent, okay, so now the next step is gonna be setting, instead of x, we're gonna put 1 is equal to 3 tangent theta. Okay, we solve for tangent, so that would be 1 over 3 equals tangent theta. So when is tangent theta equal to 1/3? That is when theta equals pi over 5 pi over 4. Let me see if that's the case. Yes, that's the case. Yes, let me double check it. Okay. Remember, we have to keep in quadrant 1, so that's very important. So let's see, 5. So okay, so 1/3 is equal to 0.33 as we know. And then tangent, okay, so let's see, let's convert this to scientific. So that would be tangent of, okay, so we'll multiply 5 times pi over 4. I'm sorry, 1 second. 5 times pi divided by 4 is equal to 3.993. Okay, so now we take the tangent, that is equal to 0. So yeah, that's not it. So I believe this one should be pi over 4. Let's see now this one. Okay, so now pi over 4 pi, okay, so let's see, pi divided by 4. Now we take the tangent, 0.0, yes, okay, 0.02, okay. Okay, so now 1/3 0.333, and then pi divided by 4, 0.78. Okay, so what I'm gonna do, since I think we need to change it to degrees, this is from degrees to radians. So radians, okay, so now I put radians, then I put tangent, that's 0.3. Yeah, it is close to it. 0.25. Okay, let's see one more time. Let's see. So we're in radians. Okay, so now, so I should put pi divided by 4. I'm sorry. Pi divided by 4, 0.78, and now I take the tangent. We're on radians. 0.25. Okay. Okay, so what I'm gonna do is I'm gonna let theta equals to pi over 4. Okay, from that, okay, so now that we have the new, I recommend you verify these thetas, these thetas, because they have to be in quadrant 1. Okay, I already did this in advance, so but I'm just gonna show you what the next step should be. Okay, so now that we have the new limits, so this integral will become zero to pi over 4. Okay, so now I told you that x is equal to 3 tangent theta. That means that dx is equal to 3 secant square theta. Okay, so knowing this information, I can just plug, and remember that this integral here, this square root is gonna become secant theta multiplied by 3. Okay, now x cubed is equal to 3 tangent theta cubed. So what I'm gonna do is I'm gonna put 27 tangent cube theta, and then dx is this here, so that would be times 3 secant square theta, and all of this is d theta. Okay, so now this is the new integration that we have to do in order to solve the original integral. So these 3 cancel with this, one of these one cancel with this, so we're left with secant theta. Okay, so now the 27 we pull it out, so that would be 0 times pi over 4, and then it becomes tangent cube theta secant theta d theta. So this is what we need to solve, and this you can do say using substitution by parts or something, or trig identity substitution. This is more likely to do with trig identity substitution. Okay, so the way, and then if you evaluate this integral, which I'm not gonna work, but I did it on the computer on Mathematica, I get 5.2721. And I also calculated the original limit, and I got the same answer. So that tells me that I do have the correct limits and the correct functions, trigonometric functions within the integral. Okay, I'm not too happy about this, because when I was doing it I also got a little confused. Let me do something. Let me see something. Let's see if I can do it, because here it's not letting me do it correctly. So I go to Wolfram alpha, and then I see that okay, so now I see. So now I'm gonna put is 1 equal to tangent then I have to put pi, then I have to put divided by 4, and of course I need to put 3 next to tangent. So is 1 equal to 3 tangent of pi over 4, and the answer it gives me is tangent is okay, I see, 1 second, 3 times, then I'm gonna put, so I have to do it through so now let's see if this works. Pi divided by 4. Okay, now let's see. Yeah. Yes, I think I know what I found, what I did wrong. Okay, I know what I did wrong. That's why I wasn't getting the answer. Okay, now I know why. Now I feel happy. Remember that I told you that we're doing 3. I got put 3 because I was doing another thing and then I was doing another integral. So this should be 3. This should be 3. So now this has to be pi over 4. Because this becomes 1. Okay, so now okay, so now let's see. So now when is tangent equal to 1, that's what we need to do. When is tangent equal to 1, we see tangent of pi over 4 is equal to 1. That is correct. So now if when is tangent equal to pi, so basically we're saying when to get this, to make sure that we're getting this here, we need to do this equation. So now I was putting 1 because I was getting ahead of myself. I was doing another problem before. So it should be 3 over 3, which is 1. And that's what I was confusing, because I was leaving the 1 here and then the 3 here, but I forgot to take it out. When I was trying to do it, I was mixing it up. Okay, so now make sure this is when theta equals pi over 4. Okay, so now it works out. Now if you do this here, 0 to 3 of this function here, you're gonna get the same answer. The same answer as you do this one, 0 to pi over 4 of tangent secant. So I wanted to show you 2 things. The main important thing, of course, was the limits of integration, but the second thing was that a little reminder of how to use trig substitution, a special trig substitution for this kind of patterns here, radical patterns, because you have an x cube here, so that might throw you off. But see, all you get rid of those things by having these equations here, x equals 3 tangent theta, and all those equations, they basically come from the radical. Everything, all these equations and the secant thing, they all come from the same procedure by looking at the radical. So make sure you concentrate here. And forgive me about this here. I really wanted to work it out, so that's why I work it out on my notebook. You can see, but I wanted to make sure I did it correctly, so that's why I went back and I tried to do it. All right, thank you, my friends. Don't forget to subscribe.